Okay, so I'm going to be talking tonight about panic. It's a feature in Go, and we'll be talking about that tonight. So I'll be covering what panic is, what you see when you get a panic, how to regain control after a panic. We'll talk a little bit about runtime panics and how to identify them, and then there'll be some advice on when and how you should panic and when and how you should recover. Okay, so basics is it's a mechanism that Go offers, and it's used for handling and reporting runtime errors. It gives you a lot of detail about where the problem happened. Your program exits, and if you don't want to exit, you have to call recover in a deferred function, and be very careful when you call recover because there's a lot of gotchas in there. So let's get a bit more detail. So as I say, it's a built-in function. It takes a single argument of the empty interface. You can pass anything into it. And it's used by the runtime and the standard library to report errors that can't be caught at compile time. And you can use it too. And there's some examples there of how you might call it yourself. And it is a function. It's not a keyword or some magic in the language. And it will appear in stack traces if you look for it. So here's the example we're going to work through. This is a bit of code that will panic. So we've got a function. So main calls function f. F defers a print line statement and calls this function panicker. Panicker is supposed to return a couple of values, and the first things it does is it defers a couple of more functions, and then it prints out a little message saying it's about to panic, and panics, and then there's a bit of code after that. So what happens when you panic? The first thing is the execution of the current function stops. So no more of that. So no more of the code. None of the code after the panic statement on line 23 gets run. So 25, 26 and 27, those lines do not get executed. The next thing is any deferred functions are run. So in fact, the only thing that gets run after you call panic is deferred functions. They're called in the reverse order that they're defined, or that they were deferred rather. So it's last in, first out, and only those functions deferred before the call to panic are called. And it calls all of them in the call stack up all the way up until it either exits or it gets caught. And they're called from the panic function itself. So it isn't stack unwinding isn't happening. It looks a little bit like stack unwinding is happening, but it isn't. And it's only the deferred functions in the current Go routine as well. So if you've got lots of Go routines running, the only deferred functions that you get called are the ones in your current function, in your current Go routine, the panicking Go routine. So next thing that happens is that the panic is reported, and this means it prints out the word panic and then the value that you passed to panic and a stack showing you where the panic occurred, and we'll talk about this more later. Then the program exits, and it exits with exit status 2, so you know if you've got another exit status, it wasn't a panic that killed your program. And here's what you see. So this is the output. So you see the about to panic message, which was the first thing that we printed in our panicker function. Then you see the deferred function called in reverse order. So the last is first and the first is last. And then you get the deferred function from the function that called it. And then there's the output from panic. So you see the panic message, you see the panic string, then the message that you passed, and then some details about what get called. So it shows you that main called F and F called panicker, and it shows you the file names and line numbers. So what happens if you panic when you're already panicking? So if one of your deferred functions itself calls panic, then the value that any subsequent call to recover will return is replaced with a new one. So you don't get both of the values, you just get the latest one in there, and you get the new panic location added to the stack, and we talk about that later. I'll show you an example. It's actually probably a bit more likely than you might think, because if you're panicking, your program's in an unexpected state. You thought something was happening and it wasn't. you thought the program was in a certain state and it wasn't, so it's a bit more likely to happen again. So that's an explanation of what panic is and what happens when you panic. So let's talk about what you see when you panic. So just to recap, it prints out panic and the value passed to the function and stack trace. The messages are written to standard error, which might be of interest if you're looking to capture them in when you're running your program. So the stack trace shows you for each stack frame you get the function being called with the first 10 parameter values and return values, file name and the line number, and you only see the stack trace for the panicking go routine, which I've said before. Just worth noting that the parameter values shown are the first 10 words on the stack rather than the actual the first 10 parameters as such, and because some values take more than one word. Okay, so whoops, daisy. Right. So here's an example of a runtime panic. This code will panic. You're doing a divide by 0. The runtime will catch that and give you a nice error message. And here's what you see. So this is a runtime error. So you get the runtime error string in front of it, saying that it's from the runtime error, from the runtime, and it's saying it's an integer divide by 0. So it's very clear what your problem was, and it shows you the line, the file name, and the line number where it happened from, and that's it. So now let's have a look at another thing that will panic. So this is the standard library. So the flag package. If you try and call the flag package with 2 flags of the same name, you'll get a panic. And so that's the error. And if we run it, we see this. And the first line is actually printed out by the library. So the flag package is printing out that line, and then the rest of it is from the panic mechanism. So you see the panic string and the details of the value that was passed to panic. And now there's a little bit more interest in this because it's a bit more to it. So you see main calls flag int, and it calls it from line 14 in main.go. And then you remember I said that the first 10 parameters are printed out. Well, we're not seeing that here, and that's because flag.int is a very simple function which just calls the int method on the flag set object, and it uses some default value. So if you use it in this way, you get the default some default flag set, and so the parameters. So the compiler has optimized the code away, and so if you see these ellipses as the parameter values, that's kind of what it means. It means that it's just been optimized out. But then, if you see up here, you've got a number of values on there. So the first thing looks like a pointer. The second thing looks a bit like a pointer, and then there's a value 1, and then there's a value 2. Another thing that looks a bit like a pointer, a value 4, and another pointer. And what's actually happening here is the first value being passed is the pointer to the flag set. So this is actually what gets passed around. So that notation of calling flag set .int is a bit of syntactic sugar really to make the language a bit nicer, but actually it's just putting it onto the stack. The next 2 values are the first string we passed in. So if you recall back here, passed in a string of length 1 with value f, and then a 2, and then a string of length 4, value help. And so that's what we're seeing there. So we're seeing a pointer to the string, the length of the string, and that's what you see when you pass a string on the stack. Then there's a value 2, then a pointer to the second string and the length of the string, and then the last value is the return value. Okay, and then it carries on and does some more things, but essentially that's the meat of what's happening there. Okay. So, if you want to control the information that you get when you panic, you can set the go traceback environment variable, The default value is probably fine for most purposes, but if you're having problems understanding why your program is panicking and you want to understand a bit more detail of what's going on in the program, you can set it to other values. I'm not going to talk about it more now, but that's something you can be aware of. So there. So we talked now about what panic is and what you see when you panic. So let's talk about how you get control back after a panic. So you need to call recover, and you need to call it from a deferred function. And the reason for this is because the only code that gets run after a panic is code in deferred functions. So it has to be in a deferred function, and the panic will not be propagated any further, and the function that you set up the deferred recover from will still return after all its deferred functions have been called. So there's an example here of how you of a way of calling recover. I'd personally recommend doing a little bit more. If you are going to recover, do more with it than just print it out. The default behavior is kind of better than that, but that's just for an example. Okay, so once you've recovered, you need to test the return value. This is the value that's past a panic, and if it's non-nil, then a panic has occurred, and you can try to fix it. So that's the determinant of whether a panic has occurred. But unfortunately, the behavior of the design of this feature in the language doesn't actually give you a guarantee that you're not in a panic if you do see nil, because you can panic with a nil value. Now, you shouldn't do that, but we'll come to a bit more arguments about what you should and shouldn't pass. But it can happen by accident. So, okay, so that's how you gain control after a panic. So now let's talk a little bit about runtime panics. So, if you want to know whether the panic that you received was a runtime error, you can tell by checking the type. So there's runtime errors are of a specific type, and it's a type of runtime.error. And okay, so a runtime.error, it's an interface with an error method, so that it satisfies the error interface. So it's a normal error, and it has a runtime error method which actually doesn't do anything, and it's useful to be able to distinguish a runtime error from other errors. If you want to have your own package-specific error type, this is kind of the boilerplate code that you'd need to have. Essentially, you just do as I've described for the runtime one. And so now, more interestingly, why should you have a package-specific error type? Main advantage is so that you can identify programmatically that an error came from your package. And in this example here, I've set up a type. It's not an error type, but it's just any old type here. So so my type is a string, and in the recover, if you assert that that the panic value is of your type, then it will panic if it isn't. So if you're expecting your code to panic with a certain type of error, you can panic with that error where you use it, and in your recovery, if it's not of that type, so something unexpected has happened, you can just do that assertion, and this code will re-panic. So as shown down there, the panic that we pass is just a normal string. It's not a my type of that string. So what you're doing here is you're using a sentinel error type rather than a sentinel error value. It's safer than sentinel error values. So Dave Cheney's written about the dangers of these things. Okay, and this is what you see if you get the wrong type. So you notice here you get two reports of panic. So the first one, panic knows that it's recovered the first one, and then it tells you the second error, which is an interface conversion. And then you see the main called main F5, which called panic. So we don't normally see that, but that appears because there's more code going on. So it's called the that closure function that we had in there that was asserting the type of the panic, and then that panics at line 98, which is wherever. Okay. So that's a description of runtime panics. So now let's talk about some advice on when and how to use this mechanism. Should you ever panic? Yes, you should. There are times when it's the right thing to do. So you should do it when you get something at runtime that's an unrecoverable programming error. You want the program to exit, giving details of where the mistake was made. That's the key thing. You should treat a panic almost like a compiler error. It's a bug in your code. You've got some behavior which you don't expect to see, and the language has nicely reported it to you. It tells you exactly what line of your code was at fault and so on. So now, ideally you want to panic if you can. You want to make sure that any panics you might get are early on in the program as it starts up, so that you're not crashing some long-running program. But if there's nothing sensible that a caller of your function can do with an error except to exit, then panic is a reasonable thing to do. The Go standard library uses it. The flag package, as we saw earlier, uses it. If you try and set up two parameters with the same name, it doesn't make any sense. There's nothing useful it can do. And similarly, the regex package has a must compile function, which will panic if you try and pass an invalid regular expression. So, what should you pass to panic? So, a simple string's okay. But an error is better. The benefit of this being that you can then distinguish between specific error types, as we discussed earlier. And don't pass nil, because if you do pass a nil, even by accident, then any recover that you try and do will not be able to know that it has recovered. It won't be able to know that it was recovering from a panic. It'll just think it's a no-op effect, or it looks like it anyway. Okay, so that's some advice on when and how you should panic. Now, how about recovery? This is where it gets a bit more complicated. So, you shouldn't panic when you're getting an unrecoverable error. So you don't want to recover really from runtime errors. If you've tried to dereference a nil pointer, or you've divided by 0, or all of the other numerous things that can go wrong, you kind of want your program to exit. It's better that it exits rather than trying to limp along in some bad state, and especially if it's at startup. So that's one of the things with the flag package. It's typically set up at the start of main before you've passed any parameters. So it's a very reasonable place for it to crash, and it will happen as soon as you start your program up. So as long as you've tested it at least to the extent of running it, you'll know about the bug. Okay. So you might want to use recover if the package is using panic to report errors. So if you're using a package that's using panic as an exception mechanism, then you need to recover. And so we'll talk a little bit about how to recover safely. Also, you might disagree with the package author's assessment of the recoverableness. It might be that you're trying to set something up, but if it's not available, you can work around it. So you might be prepared to recover then, though typically you should have set it up correctly. Okay, another good place to recover is in tests. So if you've got some code in your package that's trying to that's making sure that you're doing everything properly, then you want to test that it panics in the right place, and so having it in tests is perfectly valid. One of the sort of exceptional places you might want to do it is if you've got a server where you're really concerned about availability. So you've got something where maybe cost the company an awful lot of money if it ever actually isn't available, or if it fails in some way. So you might want to try and recover from a panic and try and institute some sort of disaster recovery mode where, for instance, starting up another instance of the server, and then when that other instance is up, then you can stop receiving new work and just finish off any work that you've got. So you might want to do that, but you want to be very careful how you do that, because, as I say, your program's in an unexpected state. Especially if it's a runtime error, it's quite likely that other things will fail too. So be careful. You will see panic and recover used as an exception mechanism. It can be used to you can use it to avoid having lots of if error not equal to nil, return error code in your scattered through your functions. So if you've got a deeply nested sort of tree of function calls, it can be a bit ugly to have that sort of pattern all the way through, and that's the sort of thing that people were trying to do with the try the mechanism they were going to put in. I think it was, wasn't it? And so you can end up with slightly more elegant code by doing it, and it mirrors the way that C++ and Java do things. The problems with it are it's a form of non-local goto. So you've got to be, when you're trying to understand what a program's doing, if you've got if error not equal to nil, then do this, you know what it's doing. It's very clear. With this sort of exception mechanism, it's the same problem that other languages face. C++ is the one I know best, and you get that same problem that at every point you've got to be able to recover if there's a sort of somebody just returning randomly after a function call because an exception was thrown, or in this case a panic was thrown above it. So be careful with it. It can make your code a bit more elegant. It might be useful it might be the right thing to do in a small program where you've got this behavior, but programs tend to grow. Libraries that are being worked, or packages that are being worked on by lots of people, tend to have long lifespans and get worked on by a lot of people who aren't so familiar with how it's working. So be careful with it. Okay, so now let's talk about recovery a bit more, about when you really, really must recover and carry on. Let's see how we should do that. So, problems that you have. If your function is recovered, if you've got a defer recovery in your code, then in a function, then that function will return. And typically it returns with no indication that anything was wrong. So let's talk about that a bit more. So it's about named and unnamed return values. So if you have a function with unnamed return values, then when you recover, those return values will always take on the default values. So numbers are 0, bools are false, strings are empty, and errors, most importantly, are nil. So in this example, as it says at the bottom, this returns 0 for the int, an empty string, and a nil error. So as far as the core of this function is concerned, everything's worked. So if you are going to have this sort of behavior, you've got to make sure that having returned, everything's fine. So you've got to be very careful when you do this. It's not quite enough to just recover and carry on. I think the best approach is to have named return values, and then, as shown down here, if you do recover from a panic, explicitly set the values to known values, and maybe set the error to be some non-nil value, and say, so that people can know that something's happened. Okay, actually one more. Yeah, so actually this, just coming back to the issue around nil panics. If you do have a nil panic, this code can't do the right thing. It will still recover, but so the panic won't be propagated any further, but the you won't go through any of this protection code here of setting an error and forcing all of the return values to known state. Okay, so another problem with it. This is coming back to the issue around the sort of exception mechanism, is that the behaviour of a function is more complicated than reading the code might imply. You've got to assume there can be a return statement after any line if there's a panic. Now, if all you're going to do at the end of all of this is to print out a stack trace and a helpful error message and then exit, that's probably okay. I mean, your program's sort of kind of in a bad state anyway, so exiting's fine. If you're hoping to carry on, then you need to really understand exactly the state that your program is after any of these states. So you can't assume that code lower down in a function is going to get called if you have a panic. This is kind of quite an important one. So if you've got tidy up code not in a deferred function, then it doesn't get called. So you see a lot of the time you have a file is open. You open a file and then you defer the close. Now that's good. If you don't defer it and you just say, oh no, I'll just remember, I'll close it on the last line just before I return, then that close won't happen. So you'll get a leak of a file descriptor there. Now there's been there have been some performance problems with defer in the past. They're minor. They're not very important anyway, but if you really are concerned about them, they're getting substantially resolved in Go 1.14. So there's been some very sort of clever work done on that. So use defer. It's the right way to do things. It's a very nice feature in Go as well. It's a good thing. So when you recover, checking the panic values. So you can check to see if it's a runtime error, and then decide whether you really want to recover, but probably best is to actually check that it's explicitly a type of error that you are interested, that you are expecting, and repanic if it isn't. So that was the example we saw a little bit earlier. Okay. So that's mostly it. There's a bit of bonus material here now. So as I've discussed through this talk, there are a few problems with recover. Firstly, you only see the latest panic value. If you panic and then one of your deferred functions panics again, you only see that second panic. You only see the value of that. So somebody might have given you a nice helpful message at the sort of lower down telling you what the problem was, but you lose that because it gets overwritten by the latest panic value, and you can't detect that panic has been called if a nil value is passed. And so, kind of a proposal, if anybody from the Go language team is listening to this, might be nice to have a new recover function, recover all, which can return a slice of interfaces. So this then, you can know that a panic has occurred if this slice isn't empty, if the length of the slice is non-zero, and you can also determine all of the panic values you've got. So it's more useful if you want to sort of understand a bit. If you want to do recover, this is more useful. Okay, so these slides, which I've gone through quite quickly, they're available on GitHub, and there's speakers notes with them, so you can sort of read what I've been saying. There's a few example programs, and there's a little program that sort of demonstrates how panic behaves, and also in that under my GitHub stuff, there's a little utility program for, provides you with a package specific error type. So it just writes the boilerplate code for you. Okay, that's it. I hope everybody understands panic a little better than they did at the start of the talk, and good luck.